Now we are moving on to the reflection portion of spherical mirrors. Okay, so the reflection portion, reflection by spherical mirrors. Reflection by spherical mirrors. Okay, so consider a concave mirror. So it's having a pole. So along with me, you also take in your notebook, you also draw a concave mirror. It will be having a center position, means the midpoint of the aperture is the pole. So this one will be having a center called center of curvature, and a imaginary line will be drawn from the pole through the center of curvature. It moves on. It's an imaginary line. Don't think that there's a line like that. No, it's an imaginary line for our calculations. Okay, we want to do some calculations, so we are imagining that there's a line from the pole to from the pole it passes through the center of curvature, and the midpoint. You have to take note that whenever you are drawing like this, you have to use your scale and pencil. Calculate the distance from the pole to the center of curvature. Let it be 10. If it is 10 centimeter, then the pole should be, the principal focus should be at 5 centimeter. You have to calculate and draw. You have to calculate means what? You have to measure the distance and you have to draw it. Otherwise, it will be a big problem for us. In this chapter itself, we will be discussing image formations. Then you will face a lot of problems. So, first of all, you have to draw using your scale and pencil. Okay, and the distance from here to here should be equal to the distance from here to here should be equal to the distance from here to here. That means from pole to focus should be equal to focus to center of curvature. Clear? Okay, so draw it like this. Okay, so this is it. Now we are moving on to the reflection portion. So from an infinite position, I have told you parallel rays. If an object was kept at infinity, if the object is kept at infinity, only parallel rays will come, isn't it? Only parallel rays will come. So I am drawing a parallel ray parallel to the principal axis. A ray, the incident ray is parallel to the principal axis. It hits on the surface of the pole. It hits like this. This was the mirror. The incident ray hit on the surface of the mirror. What will happen? We have discussed this. What you imagine here? What will happen here? They will reflect. How? How they will reflect? They will reflect in such a way that they follow the laws of reflection, which we have discussed. They will follow the laws of reflection and thus they will reflect. And so, in order to follow the laws of reflection, what we have to draw? An imaginary perpendicular line called normal. Imaginary perpendicular line called normal, and the angle of incidence will be equal to angle of reflection. Clear? The angle of incidence will be equal to angle of reflection. Clear? So this is the incident ray, this is the reflected ray, and angle of incidence will be equal to angle of reflection. So listen, and before coming into this, one small portion. I have told you concave mirrors we have two types of spherical mirrors, concave mirror as well as convex mirror. There are two terms which we can define these two mirrors separately. Concave mirror, this is concave mirror. Concave mirrors are also called converging mirrors. Concave mirrors are also called converging mirrors. So what are converging mirrors? Converging mirrors means whenever a light ray is hit on the surface, they will bring it together towards inside. So whatever ray is coming, this one will be hitting inside. That means this is curved inside, like this, it is curved inside. So whichever ray is coming, it will be concentrating towards a point inside, it will come towards it. Okay, so they are converging, the light rays, the reflected rays will be converged together. But what will happen in this case? In case of, so don't forget, concave mirrors will be converging mirrors, because the reflected rays will be converged together, come together, come closer. Clear? Okay, but what about this one? What about this one? Convex mirrors, whenever a ray is incident on the surface, it will diverge. It will be scattered away. It will diverge. It will diverge. When it hits, it will diverge. Okay, they will be scattered away because this is curved outside. So this, when it is curved outside, something hits, it will move away. It will move away. So these type of mirrors, convex mirrors, are called, also called diverging mirrors. So concave mirrors are called converging mirrors. Convex mirrors are called diverging mirrors because of the peculiarity of their reflecting surfaces. Clear? Clear. Okay, so here, so what will happen here? What will happen here? Here, the ray is hit on the surface. Okay, so if this is the point of incidence, so what I have to draw? I have to draw a normal. So through which position the normal passes? Through which position the normal passes? Okay, for example, if you take a circle, this is the center, and if I take a point over here, this is mathematics, if I take a point over here, I want to draw a perpendicular from this point. What I will do? I will draw a tangent, the line passing through the point. Okay, then what I will do? I will take a protractor and draw a 90-degree line, and that 90-degree line will pass through the center. If I take a line over here, if I take a point over here, and if I want to draw it perpendicular, I will draw a tangent, the 90-degree line will pass through the center. If I take a point over here, the 90-degree line will pass through the center. If I take a point over here, the 90-degree line will pass through the center. So if I take the point of incidence is over here, so through which direction, through which point the normal passes through? Through which point it was passing through? Whichever point we have took. This is the part of a circle or a sphere. So this is the surface of the sphere. This is the surface of the sphere. So from the sphere, from the surface, if I want to draw a line from the point, what will happen? It will pass through the center. So here this will pass through, the imaginary normal will pass through where? The center of curvature. The imaginary line will pass through the center of curvature. Clear? Okay, so this is the angle of incidence. There is no doubt for you. This is the angle of incidence. Clear? Okay, so how, and one more thing, whenever you are drawing light rays, this is important. The arrow mark is important, because we need to understand whether the light ray is coming towards the mirror, or if it is moving away from the mirror. We need to understand. Clear? Okay, so the light ray comes and hits on the surface, and at the point of incidence, the imaginary normal, the perpendicular line normal, will be passing through the center of curvature, as I have explained it here. So then, if I want to draw then the reflected ray will be reflected. The ray will be reflected according to the law of reflection, that is, angle of incidence will be equal to angle of reflection. And how it will happen? The angle of reflection will be equal to angle of incidence, and thus it will pass through which point? It will pass through which point? The focus. In order to follow the law of reflection, that means angle of incidence is equal to angle of reflection, the reflected ray, if the ray is coming, the incident ray is coming parallel to the principal axis, the reflected ray will be moving through the principal focus. Okay, so the first one is if the incident ray is parallel to the principal axis, the ray will be passing through the focus. Why it is passing through the focus? In order to follow the laws of reflection. So in order to follow the laws of reflection, it will pass through the focus. Okay, then if a ray, the next type of ray is in concave mirror, principal focus, center of curvature, the midpoint is the focus, pole, focus, center of curvature. If a ray is coming through the focus, if a ray is coming through the focus, what will happen? How it will come? That means the parallel rays, I have told you in the beginning, if the tree is at infinity, only parallel rays will come, isn't it? But if the tree is nearby, then this ray will come, this ray will come, like this come, all the direction the rays can come. So this parallel line will be coming from infinity and also from nearby. Nearby also the parallel rays can come, but other than parallel rays, all the other rays will also be incident when the object is nearby. Okay, so the parallel rays will only, so for example, if an object is at infinity, the whole rays will be what? Pole, focus, center of curvature. From infinity, every ray will be parallel. From infinity, every ray will be parallel to the principal axis, and through which direction it will move after reflection? They will pass through the principal focus. They will pass through the principal focus. So this principal focus is the meeting point or the intersecting point of all the rays coming parallel from infinity. So the principal focus is the intersecting point of all the rays coming parallel from infinity. Okay, so only parallel rays will come when the object is at infinity, but when the object is nearby, not only parallel rays, but the rays can come like this, the rays can come through this way, the rays can come like this, etc. It can come through different ways. Okay, so that is why we are discussing different incident rays. First ray is the ray coming parallel to the principal axis, and it will go through the focus in order to follow the laws of reflection. Okay, so now the next incident ray is the principal focus. Whenever you draw it in your notebook, whenever I am drawing, you also draw. You take out your pen and pencil, paper, scale and pencil, and you draw it out. So we have to keep on drawing these images because it should be a part of our life. Then only we will be able to answer the questions for our board exams. Okay, so now this is principal focus, this is center of curvature. Now first incident ray was parallel to the principal axis. Whenever an object is near to the mirror, what will happen? It will always, not only parallel rays but also other rays will also come and incident on the mirror. Okay, so now I am considering the second type of ray, that is the ray is incident through the focus and it will incident over here. Okay, so what will happen here also? What I can say, at the point of incidence I need to draw the principal, the normal, 90-degree normal. I will be drawing the 90-degree normal which is passing through the center of curvature. So this is the angle of incidence, and so in order to make equal angle with the normal, the ray will be passing parallel to the principal axis. So this is the second type, when a ray is coming and hitting on the mirror through the principal focus, it will go parallel to the principal axis after reflection. When a ray incident parallel, it will go through the focus. When a ray is incident through the focus, it will go parallel to the principal axis. Two types. Now the third type is pole, focus, center of curvature. Whenever a ray is coming through the focus, through the pole, whenever a ray is incident at the pole, at the point of incidence, the pole which is the 90-degree line, that is the principal axis itself, isn't it? So it will make equal angle with the principal axis. Whenever a incident ray is hit on the through the pole, whenever a incident ray is coming through the pole, it will make equal angle with the principal axis. It will make equal angle. In order to follow the laws of reflection, it will make equal angle with the principal focus. So principal axis. Clear? Now I have told you the importance of arrow mark, isn't it? If there was no arrow mark, if there were no arrow mark, what I can understand? I may take this as the incident ray, or even I can take this as the incident ray. So whenever the teacher is correcting, they will be confused. So what you have intended, we may not understand. The teachers, the evaluators won't understand. So we have to make it clear by drawing the arrow mark that through which direction it is incident and through which direction it is reflected. Clear? Okay, so that's important. So this is the third type, that is whenever a ray is incident through the pole, it will move parallel to the, it will make equal angle with the principal axis. Okay, and the last type of ray, that means we will be considering only 4 types of rays. There are a lot of other rays also. The rays can come through different ways, but we will be, for our consideration, we will be only studying 4 types of incident rays and through which direction they will be reflected. Okay, and the 4th type, principal pole, principal focus and center of curvature. The 4th type of ray, the incident ray will be coming through the center of curvature. The incident ray will be coming through the center of curvature. Whenever the incident ray is coming through the center of curvature, what will happen? Through which direction it will move? Just try it out. Through which direction it will move? Okay, listen. This is the normal 90-degree line. This is the normal. Okay. This is the normal. So if this is the angle of incidence, this is maybe 5 degree. If I reduce the incident ray 5 degree, if I reduce the angle of incidence again, this may be 3 degree. And if I reduce it again, if the angle of incidence is coming again, this is 1 degree. Then if again it is coming through the normal, if the ray is coming through the normal, what is the angle of incidence? What is the angle of incidence? The angle of incidence is 0. It decreased from 30, 25, 3, 5, 3, 2 and 1, 0. So then what should be angle of reflection according to law of reflection? Laws of reflection. Angle of reflection also should be what? 0 degree. Isn't it? Okay. So listen, when the ray is, so 0 degree means what will happen? If the ray is incident through the normal, the ray should make 0 degree with the normal. So it will retrace its path. Whenever an incident ray is coming through the normal, the reflected ray will also move through the normal. That means it will retrace its path. Clear? It will retrace its path. So this phenomena is called as normal incidence. This phenomenon is called as normal incidence, which is very important for your multiple choice questions and all. Okay, normal incidence. Clear? So here, listen here. The ray is coming through the center of curvature. It hits over here. So at this point, if we want to draw a normal, through which point it will move? It will move through the center of curvature. So the normal will be passing like this. That means the incident ray has incident through the normal. That means here what has happened? Normal incidence has happened. So what will happen to the reflected ray? It will retrace its path. So this is the 4th type, that is whenever a ray is incident through the center of curvature, it will retrace its path because it has to follow the laws of reflection. So these are the 4 different types of rays. Okay, and using these 4 different types of rays, we will be explaining how image is formed. I told you, when I am standing in front of a mirror, I am able to see myself on the mirror. Why? How it is formed? Okay, that image formation, how that image is formed? That image formation is explained using these different types of ray diagrams. Okay, so what we have to understand is, in order for an image to form, what should happen is minimum two reflected rays should intersect or meet. Important, very important, very, very important. If you understand this, then the image formation is clear. That means at least minimum two reflected rays should meet, and that meeting point will give you the image. For example, if you don't understand, it means you note it down, this one, minimum two reflected rays should intersect or meet for image formation. Minimum two reflected rays. That means here the rays come, incident ray will come from an object, it goes through the focus. Some other incident ray will come through the focus, it will come parallel to the principal axis. So these these reflected rays should intersect, not the incident rays, the reflected rays should intersect, and at the point of intersection, who will be formed? The image will be formed. Clear? Okay, so we will discuss these image formations in the next class. Okay, it will be very clear to you. When you just keep this in mind, the reflected rays, minimum two reflected rays should meet for image formation. Then that's how we are able to see things in the mirror. Okay, the incident ray from the mirror, from the object, hits on the reflected surface, it will reflect, and those reflecting rays, at least any of these two reflecting rays, when it meet together, that meeting point will give you the image. At that meeting point, the image is formed. So when the reflected rays are intersecting, the image is formed. Important. When the reflected rays are intersecting or meeting together, image is formed. And at the point of intersection, the image is formed. Clear? Okay, so we will be discussing this in detail. The image formation of concave mirror, convex mirror, we will be discussing. This you have to have the clear-cut idea. Why this is happening? Because in order to follow the laws of reflection, the incident ray will be passing through a particular direction in order to have angle of incidence is equal to angle of reflection. Okay, so keep all these things in mind, all the basic things in mind, all the terms related to spherical mirrors in mind. So these all things will help us to do the image formation. Okay, thank you.